Hi friends, after looking at various comparison plots, now it is time to see some relation plots. It's a plot which tries to find the relation between two features. So among the relation plots we see in these sessions what a scatter plot is, what a bubble plot is, what a parallelogram is, and what a heap map is. So let's begin with the scatter plot. A scatter plot consists of a series of individual data points, each representing a value of one variable, usually the independent variable on the horizontal axis, and the value of another variable, usually the dependent variable on the vertical axis. So that's usually, but it can also be both the variables on the x-axis, y-axis can be independent variables. So as we discussed in our previous case, with this scatter plot conveys a lot of meaning. So if as mentioned here, if the horizontal axis has independent variable and vertical axis has dependent variable, that means x-axis talks about input, y-axis talks about output, and if we can find some relation between these two, then we can say that that input has some meaning in our database with respect to the output, so we can retain that input. So when it comes to the dimension reduction, and another type is use both the axes for the independent variables, and if we find any meaningful relation among them, it means that we have redundant data, redundant feature, so one of them can be removed, so thereby we can reduce the dimension. So that's one advantage of working with the scatter plots. The key feature of any scatter plot is made up of data points. It has got two axes, and here we are trying to search for the trend line, and yes, we do need labels for clear understanding of what we are trying to represent there. So where can we use them? So the common use cases is exploring relation between two continuous variables. So if you are trying to explore the relation between two continuous variables, then this would be a better choice. If you are trying to identify patterns or trends or correlations in the data, yes, of course, this will be a better choice. And if you are trying to detect outliers or anomalies in the data set, we can use the scatter plot and see where the major points are spread out. So we can look at the region where the major points are spread out and the way it is spread out, the pattern or trend and all that. And any points which are far away from that can be identified as outliers. Or if a whole data set is talking about one trend and few talk about other trend, then you can identify that as an anomalies and so on. So it can be used for assessing the strength and direction of the relationship between the variables. Yes, how strong the two variables are related and in what direction they are related. So if they are related in positive direction or negative direction. Positive direction means with increase in one variable, other variable value also increases, and negative direction means with the increase in one value of variable will decrease the other value of the variable. So that's identifying the strength and direction of the relationship. So in case we are using scatter plots, we need to make sure some of these best practices so that we can achieve the maximum benefit out of it. So first thing is choose an appropriate scale for the axis to ensure that the data points are spread out evenly across the plot area. So before beginning, just look at the minimum maximum values of each axis we want to plot, and make sure that both minimum maximum values are spread out evenly. So use appropriate scales along the two axes so that the spread out is even in both the directions. So that way, so we can fit all the data on one screen at the same time. It can be easily visualized about the trend pattern and all. So it is better to use various colors, shapes, or markers to distinguish between different groups or categories within the data set. So once we have various data, then we can work with the colors or shapes or markers to distinguish between the different groups or categories within the data. So we are talking about various category outputs. So in that case, you can represent each category data with a different color or different markers so that it becomes easier to identify the data belonging to which category, and we can make out for each category what the trend is, what the pattern is, and so on. So it's always recommended to add title and access labels to provide the context and clarify the meaning of the variables being plotted. So just a plot will not help. So it needs a proper title so that we can understand what the plot is trying to convey, and the axis labels are a must, because without which we cannot understand what we are talking all about. And then consider adding a trend line or regression line to visualize the overall trend or relationship between the variables. So instead of just plotting the scatter plot, if you can identify the trend line, so better mark it on the scatter plot so that it gets highlighted, and it conveys the direct information to the viewer what you are trying to convey there. So you are trying to say that there is some positive correlation between the two variables you are talking about. So the data is showing a positive trend. Then you can add a regression line or regression curve to that so that you can highlight what you are trying to say. And be mindful of the outliers that may skew the interpretation of the data, and consider removing or addressing them appropriately. So when there are outliers, make sure not to use them for making conclusions, like adding the trend line or regression line and all that. So make sure either remove them before doing this activity, or mark them appropriately as outliers, and without using them, use the regression line and highlight what you are trying to represent. So in one uh, plot, we can convey many meanings, like which one is outlier, which is being neglected, and after neglecting, what trend line is or regression line is and all that, and that's going to overall convey how the two variables are related. And if you're talking about multi-class situation, then each class will be data of each class will be represented with the different colors or markers, so that will distinguish. So you can use multiple regression lines, trend lines on single plot and show that each variable is related with another variable in different classes in what way, and all those details can be represented on one plot. So here we can see that there are various types of plots. So first one, the top left one, shows a strong positive linear relationship between them. So x-axis and y-axis are two, and when they are plotted, so we do find that the spread is in only one direction, that is the minor diagonal direction. So this, as input is increasing, output is also increasing, but the spread on the other direction is minimum. They are very well attached to each other on one direction, that is on the primary diagonal direction. We don't find much variation, but on the minor diagonal we find too much of variation. So that talks about positive linear relationship, and it is strong because it's almost approximating a line. Whereas the top right is talking about something a negative, going downward, as the x-axis is increasing. um, on average the y value is reducing, but the spread is almost equal in both the directions, like the main diagonal and minor diagonal. In both cases it is almost high. So but still a trend is visible that it is going downward, so we can say that it is a negative correlation. Looks like a straight line, so it is linear, but they are not very well connected on the other axis. Therefore we cannot say it is strongly correlated, we say moderately correlated. The left bottom, if you look at it, so we don't find any relation between the x and y axis. We don't find any pattern on that, so we can say that there is no relationship between input and output. If input is a independent variable, output is dependent variable, then we can say that this particular input will not contribute for any of our future work in the further processing, so this particular feature can be eliminated. But if this is between two features, then we can say that the two features are independent of each other, therefore both of them are necessary for our future work, so we need to keep them. In case if they are on the above two plots, if you see there are somewhere relationship, and that is between input and output, we should keep that input. If it is between among the inputs, then the two inputs are somehow correlated, so one of them can be eliminated to reduce the dimensionality of the data. Lastly, we can see the bottom right plot. So here again we can find a trend there, but definitely it is not a linear one, and we can see that they are thickly populated along a curve. So we say that it is strong correlation is there between input and output, but we don't find any line fitting to that, so we say it is a non-linear relationship between the x and y axis components. So if x is independent, y is dependent, then we can keep this. In case we are using a complicated mechanism to relate input and output, but if we are only trying to work with linear, then this type of data may not be easily represented. We need to do it in a little more complicated way. So like we can divide this x-axis into two parts. So in the middle, first part you can see that there is positive correlation, and the second part you can see there is negative correlation. So we can talk in if then else logic about the relationship between input and output. So that's all about scatter plot.